What's up, y'all? Welcome back to the channel. In this video, I'm going to be showing you guys how you can create some extremely realistic and cinematic Earth renders entirely in Blender. I know there's a lot of other tutorials out there on creating Earth in Blender, of course, but honestly, I've always been a little disappointed with the results that a lot of those produce, and so I wanted to share with y'all my method for creating these extremely realistic and extremely cinematic Earth renders in Blender, so that hopefully you can improve your artwork and hopefully you can learn things along the way that will help you improve your workflow and your projects in the future. And just one more thing before we jump in, y'all, if you want to get the exact project file I used to create these renders, then that is available over on my Gumroad for $2. It uses just a slightly more complicated cloud material than the one I create in this video, and it includes 2 extra high-resolution cloud textures, so y'all can check that out if you like. But without further ado, let's jump into the tutorial. So, jumping into a new project file, hop over to our render settings. Let's switch over to Cycles, GPU Compute, 128 render samples, then come down to Color Management, and I'm going to do medium-high contrast. We'll come and play with our exposure later too, though. Now we'll go ahead and delete the default light. So now we're creating a planet in Blender, so obviously we're going to need a sphere as our object in the center, but we're going to do something a little bit different. I'm going to add a subdivision surface modifier to the default cube. I'm going to apply that with 4 levels of subdivision. Then we're going to hop over into geometry nodes, add a new geometry nodes modifier, and we're going to do the simplest geometry nodes tutorial of all time. We're going to grab a set position node, a position node, a vector math node, and a math node. Now set this one to distance, plug this in, and grab another and make this a scale operation. Plug the distance into the bottom of the math node, switch this to divide, and now you'll see that by plugging this in, and now we have a perfect sphere of radius 1 instead of that sort of subdivided cube look. And so the reason I'm doing this instead of using the 2-sphere operation is because now I can slap on a subdivision surface modifier right above this, and I can use different levels of subdivision for my viewport and my render. And, every time you're doing a subdivision, it doesn't perfectly create a sphere, but now with this modifier, which I'll just name the 2-sphere modifier, we get a perfect sphere no matter what our subdivision is. And so that's not a big issue, but when you're dealing with really fine details, you will run into a problem otherwise. Shade that smooth now, and let's hop over to our shader view. Click over to rendered, and I'm going to hop over into my world, set the strength of my background to 0, make it pitch black, Shift A, and grab a light sun lamp, come down here and give it a strength of 10. Now I'm just going to kind of line us up a cinematic shot, camera to view. I'll give my camera a focal length of 175 millimeters. The reason I'm doing this is just, if you look at a lot of reference photos for space shots of Earth, a lot of these are taken with like telescopes essentially, and a telescope is just a camera with a really long focal length, and so this gives us just more of a realistic feel to the render rather than using the default 50 millimeters. That's actually a really good piece of advice just in general. If you can avoid using the 50 millimeter default camera focal length, then that will help you drastically improve your artwork. I'll also check render region. And there we go. That's a decently cinematic looking shot. Obviously, you can do a whole bunch of different things as well. Now we're going to switch back to object, and we're going to start building our planet material. So I'm going to name this to Earth Surface, and we're going to import some texture maps. So fortunately for us, NASA is very nice, and they have given us a whole bunch of maps that we're going to need to create the surface. So I'm just going to go in, and for this, I'm going to be using color map 3. Obviously, I've included a couple here as well. So you might want to experiment with those, but just use color map 3 for this specifically, because otherwise you will run into some really small issues with the masking that we're going to do. Press Ctrl T to bring up the texture coordinates, and I'm actually going to click this snap button here, so that way everything snaps to a grid. It just makes everything feel a little more clean. And now if I plug my texture here into the surface, you can see we've got a really, let's call it not good texture going on right now. So we're going to switch this from flat to sphere, first of all. And then we're going to slide this over. We're going to use object coordinates and grab a vector math node. We'll get rid of this mapping node as well. Set this to scale and scale it by 10. And there we go. Perfecto. Now, of course, the ocean and the land look a little bit different in terms of their roughness and their specularity in real life. So we're going to have to mask out the ocean versus the land. To do this, let's go ahead and grab a math node. And we're going to set this to compare. And I'm actually going to slide all of this over a little bit and grab a separate color node. So what we can do is we can set this to HSV, we can use the hue value, and we can compare the hue of our ocean, which if you come over here and select like this, and you can use an RGB node, go ahead, select the ocean. And now if we compare these two with a value, we have some sort of give value here, epsilon. And this is set to 0.5. I'm going to set this to 0.27. Now, as you can see, lowering this comparison value has given us a little bit of an issue where part of the center of Africa is supposedly an ocean now. But fortunately, we can actually solve this pretty easily. Control-Shift-D on the image texture, go in here, and we're going to replace this with Earth Height Map. Grab a color ramp, plug this color into here, then grab a mix node, and we're going to plug this into the factor here, set B to 1. Now if we set this to ease and drag this all the way over, just barely giving any give, I'll actually set this to 0.001 manually, you can see we have pretty much fixed it. I set this to constant. Still a little bit of an issue, so maybe we'll raise that epsilon just a bit. Make it like a 0.31, and there we go. Now we can go ahead and slide this down, plug our image texture back into the base color, then grab a mix node again, and plug this into the factor. And so 0 is our ocean, and 1 is our land. And so we're going to adjust the roughness first. For the roughness, we want our land to be perfectly rough. And we want our ocean to be like a 0.2, maybe 0.3. We'll go with 0.25. Then Control-Shift-D, and we're going to adjust the specularity. So the land should have 0 specularity, and the ocean can get away with around a 0.8. I found looks pretty realistic. Yeah, that looks pretty darn good. Now let's go ahead and grab a bump map. Grab our height map over here. It may take a second. Some of these files are quite large. Plug this into the height value. Plug this into the normal. And just for safe measure, we're going to use another mix node using our factor. Plug this into here. Set this to 0. And we're going to lower our strength way, way down. Something like a 0.02 is actually pretty realistic. You may want to go with a little bit more just to give a bit more of a custom effect. But yeah, that's what I'm going to use for now. I'm also going to go ahead and just move my camera around a little bit. Try and get us something a little bit more cinematic. Get some land and water. There we go. That looks pretty cool to me. Now we're going to be using some really big image files, and stuff is about to get a little more complicated, so you want to make sure you are saving your project file. Now I'm going to go ahead and rename this cube. I'm going to rename this to surface. And I'll actually just create a new collection, call this Earth. Keep everything nice and organized. And now I'm going to just Shift D, duplicate the surface, and I'm going to give it a new material. So this is going to be our atmosphere. I'm just going to go in here, and I'm going to start out by renaming this atmosphere. There we go. And then I'm going to come over here from tool to options, and I'm going to change this bump only to displacement only. That way we have the ability to change the size of our sphere just using the displacement node. And so I'm going to go ahead, delete the principled BSDF, plug my displacement node in here, set my mid-level to 0, and then I'm going to grab a math node, set this to divide by 1000, set this top value to 5. This is just giving us more sort of fidelity in the control. Plug this into the height, and now since we don't have a shader, obviously you're not seeing anything, but now this value here is controlling the scale of our sphere relative to the surface. And now we can actually start making the shader. So let's grab a texture coordinate node, and let's grab a vector math node. Now I'm going to set this to length, object into there, grab a math node, set this to subtract 1 from the length, Shift D, and now we're going to divide by our height. And so this will give us a gradient from 0 to 1 from our surface to the outer atmosphere. And I'm actually going to add just a little bit to my displacement, something like a 0.05, just to avoid some clipping issues if you're using lower subdivision spheres. By the way, I did up the subdivision to 3 for both the atmosphere and the surface, just to make things as nice as possible. Now, with all of that put together, I'm going to highlight it all, Control G to group. And now I'm going to go ahead, grab another math node, set this to multiply, plug this in here, multiply by 10, Shift D, set this to power, and plug this into the exponent slot. Now I'll actually come down here and plug this value here for our group, rename this to height, and then I'm going to grab another math node, set this to multiply, give us another node here, and I'm going to change this to density. I'll slide this over just a bit to give us some space. And now I'm going to grab a volume scatter node, plug this into the density, plug this into the output. I'm just going to shift widgets on top. Then I'm going to plug my volume into the volume shader. Just got to remember to connect that there. And there we go. Now, obviously, Earth's atmosphere is in gray. So I'm going to change this to a nice sort of bluish color. Hue of 0.63, saturation of 0.8. Then I'm going to duplicate my group input node, slide this over here, and then I'm going to plug in the color. The reason I do this is just that if you set the color first, whatever you plug into the group input node, it sets that as the default. And so it just saves a little bit of time. I also want to be able to control the anisotropy, I don't know. I want to be able to control this from here. In real life, it's about a 0.25 value for Earth. For my density, I'm actually going to go with about a 15 for now. And now I'm going to slide this up over here because you can see this is like, it's not bad. It's a really realistic fall off. Looks kind of nice. If you were just building something really simple, this would work. But the first thing you'll notice with this as being an issue is that there is no sort of like dawn or dusk. There's no sunrise redness or orangeness in the atmosphere. And of course, we want something very realistic, so we're going to need to include that. Fortunately, that's actually really easy to add. Just grab an add shader and a volume absorption node. Plug directly from the power node output into the density of the volume absorption. Plug this into here. Then grab a math node. Set this to multiply. Grab a group input node. Plug this in here. And we're going to call this our absorption density. There we go. And I'm actually going to set this to around a 25. And I'm just going to give this a saturation and a value of 0.9. And of course, you can always just plug your color into the group input as well. I like to be able to control just about everything. That way, it's easier to customize if I want to make like an alien planet or something like that. Now, the next thing we're going to do is we're going to pull a Montreal protocol, and we're going to fix our ozone issue, that being that we don't have any ozone. So grab yourself a float curve. We're just going to make this sort of quick and easy here, nothing too fancy. And plugging directly from this divide node, so that way we have a linear gradient. Plug this into the value. Grab a math node. Set this to subtract. Subtract 0.39 from the value. Now I'm going to grab a map range node. And I'm just going to use this to prevent any clipping into negative space. And I'm going to give us a pretty realistic ozone fall off. The ozone more or less spikes sort of at the mid to high atmosphere. It doesn't just fall off like the other elements do. And it has one of the most distinctive things, which is that it's very sharp in terms of how it appears. You get this very sharp sort of curve. So we're going to replicate something like that. There we go. And now if you just get another volume absorption. Now for the color we want to absorb, we're going to use a hue of 0.58, saturation of 0.9, and we'll lower our value just a little bit. Plug this into the density, add this shader, and there we go. Now, just like with all our other values, I'm going to steal a multiply node, plug this in here, name this ozone density, and I'm going to bump this up to something like a 75. Really just fixing the ozone. That's the real hack. And there we go. You can see this gives us sort of like this dark line here. And so if I hop back in here and adjust this subtract value, there you can kind of see that dark line just sort of coming down and up. I might adjust this a little bit more and then maybe knock this down to like a 65 or even like a 50. There we go. That looks a lot better. But now what we have to do is we have to add the secret sauce, which is actually over in our render settings. So what we're going to do is we're going to switch our volume bounces to 32, and we'll have to adjust our total bounces as well. Then we're going to come down to the volume step rate and change the render step rate to 0.25. You can leave the viewport alone. This isn't going to do anything, but now when we adjust the step rate in the material, this will. So set this to about a 0.01. You may want to set these values just a little bit higher if you're running a slower machine. This is pretty much the ultimate control over how long your renders take versus how good they're going to look. And so higher values are going to render much quicker, but they're not going to give you as much detail in your atmosphere. So it is, of course, a trade-off like with all things. And actually, I don't know what I was thinking. I'm going to do a way higher density here. Let's go with something like a 225. There we go. And now if we get our camera really close, you can see we get a really nice golden sunset. And let's increase our ozone back to 75. I don't know why, I just totally blanked that the density needed to be higher. But yeah, now you can see we get a much better result. And we get a really nice sunset. This is the best way to check if you're getting a realistic sort of shader, is that you actually pretend that you're on the surface and does it look real? And the answer here is that it looks quite real, I think. So now for the last bit, we're just going to create our clouds. So we're just going to keep this in the same shader because that is way, way, way more efficient. And I'm going to grab an add shader there, and I'm going to go ahead and grab an image texture node, open this up, go to that file, and we need clouds 42k.001. This is a very, very large file. It's almost half a gigabyte because it's a 42k PNG. But that means we have a lot of resolution, so we can actually get decent close-ups. Now press Ctrl T, and just like with our surface texture, we're going to be using the object coordinates, and then we're going to grab a vector math node, set to scale, and we're going to scale this by 10. And in order to make our clouds, we're going to basically be using this as a displacement texture on our actual shader. And so that'll make sense in a minute, but you're going to have to Control-Shift-D this scale node, drag this way over, drag this way over here, and we're going to do a little bit of math. And I'm going to grab a volume scatter node, and I'm going to grab a length node, just vector math set to length, plug this in, slide this over, grab a good old-fashioned math node, multiply 250, then plug this into the density and plug this into the shader. As you can see, this is just a giant white mass. And I'm actually going to jump this to 500. There we go. You can see if we actually lower this scale to a 1 and then grab a math node, set this to less than, set this to 1, you can see that if we lower this, it's sort of acting like a displacement effect. So we're going to start out now with some image manipulation. I'm going to grab a power node, and I'll set the exponent to a 0.8 just to give us a bit of a nicer fall off instead of just the linear gradient this is going to give us more or less. And I'm actually going to grab a value node now, Shift-D, switch this to divide by 10, grab another math node, set this one to add, plug this in here, this into here, and I'm going to be using a value of 0.5. This is going to essentially give us the distance between the surface to the bottom of the clouds. This is very, very minimal, of course, but it's a little detail I like to have in. Now I'm going to grab a mix node, plug this into the factor, set B to 1, Shift-D, set this to multiply, steal our divide node and our value node, and this is going to be like our cloud height, if you want to think of it. So I'm going to set this to 10, and I'm going to divide by 10,000, plug these in here, Shift-D, set this to subtract, and we're going to be subtracting from 1. Now if we plug this in, this is going to take a second. There we go. And so yeah, you can see we're getting that displacement. We do need to alter our texture mapping. Forgot about that. Set that to sphere. And now just one last thing we're going to do here, regarding our mask at least, is we're going to set this to multiply. And we're going to come over here, steal our texture coordinate node, steal this length node, grab this less than, and we're going to switch this to a greater than node, and this will just act like a height mask to get rid of anything really close to the surface, so that way we can actually have some altitude for our clouds. Again, you don't really need this, but I like it. And so we need to duplicate this again, and we're going to plug our 0.5 value into here, switch this to divide by 10,000, Shift-D, add 1, and then we're going to plug this into here, and plug this into our multiply slide here, and you can see that just gets rid of that little bit of weird haze going on. And yeah, that is a pretty nice result, if I do say so myself. But there is actually a little bit more to be done. So I'm going to drag this on over, and I'm going to grab one more multiply node, and I'm going to grab a color ramp. And so we're just doing like a little simple operation here. Set this to ease, drag this out, and this is just going to get rid of some small little clipping errors that you can't really see, but the image does have a couple just small little bits that this will get rid of. Just plug that into there. Just duplicate your multiply again now, and I'm just going to set this to like an 8. So we get just really dense clouds because we are going to alter this a bit. For our volume scatter, we're going to grab a light path node. And what I'm setting up here is actually just a modification of the cloud shader that Samuel Krug came up with over on his channel. Seriously, go check that out. It's an awesome video and a really great effect to know about. Yeah, so just want to make sure credit where credit is due. Make sure to go check out his video. This is just a modified version of that. Now I'm going to grab a math node, set to power, plug the ray depth into this exponent, set the base to 0.95, Control-Shift-D, add 1, then grab a power node again, base of 0.9, plug that in there, and now this is going to be multiplied with our density, and this is just going to go into our anisotropy. And of course, we have to turn our value up to 1 here. But yeah, that is effectively everything. That is an extremely realistic Earth. And you don't actually have to do this fancy shader here. If you just want to skip over, it actually doesn't look too bad just with your basic volume scatter, but this only increases your render times by like a really small amount, and so I'd consider it worth it. I might lower my density just a touch, maybe knock it from an 8 to a 2 there, or maybe a 4. There we go. And yeah, that is the tutorial, y'all. And so one last thing, actually, I remembered after I recorded, is that you can come in here and get rid of this mix node I added and just patch this through. That'll actually solve a couple of really small problems. Also, I know that this project file is a lot heavier than what I usually produce on my channel. I always try to make sure that, just as many people as possible can render out the things that I create. But this one, it just kind of demands being a heavy scene. But one way around this is that you can actually render out some nice HDRIs like I've done here. And these take a while to render out, but once they're done, you can of course render anything in just about a second or two. So that might be worth it if you're creating like an animation. Because, of course, usually when you're animating something over a planet, the planet is relatively stationary, and so you can get away with just having that one HDRI. But yeah, thank you all so much for watching. If you enjoyed this video, consider liking, subscribing, all that YouTube jazz. Again, the project file with the more advanced cloud setup and the extra cloud textures, that is available over on my Gumroad for just $2. It's also a nice way to support the channel if you like. But yeah, thanks for watching, y'all. I hope you enjoyed this video. I hope you learned something, and I'll see y'all next time.